at how we assess this. So again, it's on the movable pages, unlike my glasses. So report guidelines and grading criteria. So the specification is here, look, so that said 24, it should say 25, I have updated it. So there's all about the metal detector, and you've done most of that already, and it's got the circuit diagram and all the rest of it on there. But, some guidelines on how you write the report. And like I was saying to a gentleman and a young lady over there earlier, how do you get a good grade? You show me you understand. That's the overriding thing in anything to do with these skill-based modules. It's about what you've taken away from it, what you've learned. Can you get a good grade if it doesn't work? Yeah, absolutely, absolutely. And this is something that I don't think students fully understand, that getting it to work is the be-all and end-all. No, it's not. It's understanding, for example, and explaining why it didn't work, what the shortcomings were and so on, what the advantages, disadvantages, all this kind of stuff. It's a standard format submission on Phaser. Check the deadlines, but the deadlines are also contained on the assessment sheets there. I will remind you as the deadline gets close. It's not close yet. Standard report format, abstract, introduction, main body, conclusions, references, appendices. That doesn't mean to say that you have a section called main body, as I see every year on about different occasions. It just means that's where the material that your main contribution is going to be. So abstract, this work is designing, and I can see everybody's copy of that. This work is sets out to design a metal detector using small discrete components. Yep, introduction. That's where you say what a metal detector is. Main body. Well, that's where you're going to start talking about, I use multi-sim to do this, multi-sim isn't the best simulator in the world, but it's practical and available to me, blah, 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 blah. All that kind of stuff. Start with a description of the circuit. Now, there are descriptions of how that circuit works, and if there aren't, you get some help from us and we'll kind of explain what the different blocks do, so you've got something to put in your report. Then some kind of description of your design choices. Why did you decide to put all the transistors in a circle and all the resistors in a square, or whatever you've done? A little bit about any testing that you did on your circuit, the one you made, and that's quite why we get you to do the same thing, because it's just useful to be able to see the real version and the virtual version. Any simulations that you can get to work in multi-sim. Can you simulate it? No, because how do you introduce a piece of metal into the simulator to get it to beat? You can't really. But what you can do is you can break that circuit into, well, 3 obvious chunks and test each one of those chunks in isolation and the sum of the parts and all that. So some of the individual of those 3 parts demonstrate that that circuit would work if you were to simulate it from first principles. Okay, conclusions is the next bit. What do you conclude? I got a metal detector, it works. Not very good conclusions. The metal detector used is a very simplistic one. It's difficult to imagine a simpler metal detector. However, it is functional over short distances. It could be improved by having a higher gain output on the stage and a larger coil. That kind of language, that kind of description. References, well, you probably only got a couple, my notes and anything else that you've looked up on the web. Appendices, so I'd like you to try and keep it under 10 or 12 pages, including the diagrams, because I've got to mark all these. I don't want chapter and verse and massive reports. But if you want to include data sheets in there, or photographs that you've taken of something that you're particularly proud of, put them in the appendices and they don't count on that 10, 12 sides. Any questions on what you're going to do? So multiplex your time, go and do some soldering if you haven't already done it. And I'd like to see you trying to get that circuit into multi-sim. And like I say, you'll have a job running it, but you can dissect it into 3, possibly 4 sensible pieces that you can then put through standard simulation like you've done already. So you would run it up and you would inject an AC signal, you would look at the DC levels, all of this kind of stuff. And just like you diagnose with a real circuit, if you don't understand any of it, you put probes on everything. And you measure the DC levels, the AC levels, and on every single point. And that's what you do if you were using the Roden short signal generator here. You get the probe out and you probe. And you have a look around the circuit and see what that circuit's doing. Oh look, there's an AC signal there. Why? Oh look, it's 10 volts there. Why is it 10 volts there and 0 volts there? You know, it's that kind of experimentation, yeah?